You know, every time you click a link, swipe on your phone, or stream a show, it all relies on this invisible world that runs everything. Today, we're going to pull back the curtain and demystify what that is: computer networks. I mean, really think about that for a second. You click something and boom, in less than a blink of an eye, information just sips thousands of miles from some server right to your screen. How in the world does that actually work? What's happening in that split second?
Well, it definitely feels like magic, right? But it's not. It's actually this incredible hidden world full of digital highways, super smart traffic cops, and vigilant guardians, all working together perfectly to get your data exactly where it needs to go, safely and instantly.
So, to really get it, we're not just going to talk about it, we're going to build a network right here from the ground up. We'll add each piece one by one so you can see exactly how this whole amazing system comes together. So, first things first, why even bother connecting computers together in the first place? What's the point? Well, if you think about it, your computer or your phone, all by itself, is kind of like an island. Sure, it's got its own stuff on it, but its potential is, well, it's really limited. It can't easily share anything or get anything from the outside world. But the moment you start building bridges, the moment you create a network, that lonely island becomes part of this huge, bustling ecosystem. All of a sudden, you can share one printer with 10 computers, you can zap files to your coworker instantly, you can stream a movie from one device to another, and of course, everyone gets to share the same internet connection. That isolated island, it's now part of a continent. Okay, so we've decided to connect our devices. Great. But for them to actually talk to each other, they need a way to, find each other. Every single device needs an address, a unique identity in this new digital neighborhood. And here's the thing. Every device actually has two kinds of addresses. The first is its IP address. You can think of this like a temporary mailing address. Your laptop has one IP address at home, but when you go to a coffee shop and hop on their Wi-Fi, it gets a totally new one. Then you have the MAC address. This is more like your device's permanent, unchangeable fingerprint, literally built right into the hardware by the company that made it. So the IP address, yeah, it works exactly like the address on a letter. Every little packet of data that gets sent across the network has a destination IP on it. It's what tells the whole system, hey, this is where I need to end up. The MAC address, though, that works on a much more local level. Your router at home, for instance, uses this permanent hardware ID to make sure that the Netflix stream you started goes to your smart TV and not to your printer by mistake. It's how it tells all the physical gadgets apart inside your own little network. All right, so our devices have addresses. But who or what is reading those addresses and directing all this traffic? Well, that's where the hardware comes in. These are the traffic cops of our network. So the main traffic cop on your local network is your router. It's the central command hub. It knows the IP address of everything connected to it: your laptop, your phone, your smart speakers. And when you send something, the router's job is to figure out the absolute fastest, most efficient path to get it where it needs to go. Now, a router is a genius at managing traffic inside your local network. But what about getting data out to the big, wide internet? For that, you need something called a gateway. It's literally the bridge that connects your private little network to the gigantic public one. And for most of us, this gateway function is just built right into that same box we call our router. And then, of course, we have the server. The easiest way to think of a server is like a central library or a giant warehouse. It's just a really powerful computer that's dedicated to storing and sharing stuff. When you go to a shared drive at work or stream a movie, you are the client asking for a resource from a server somewhere. Okay, so we've got our local network all set up. The pieces are there. But how does this little ecosystem in our home or our office actually connect to the rest of the digital world? Let's zoom out a bit. This is where you really see the difference between a LAN and a WAN. A LAN, or local area network, is basically what we just built, the network inside your house or a single office building. A WAN, or wide area network, that's what connects devices over huge distances. And the biggest, most massive one of all? Yep, that's the internet. It's really just a global network made up of millions and millions of smaller networks all talking to each other. So, how fast is that connection? Well, that all comes down to bandwidth. And the water pipe analogy here is absolutely perfect. Bandwidth is just the width of your digital pipe. The wider the pipe, the higher your bandwidth, the more data can flow through it at the same time. And that means faster downloads and smoother streaming. But speed isn't just about how wide the pipe is. It's also about delay. We call that latency.
So if bandwidth is the pipe's width, latency is how long it takes for a single drop of water to get from one end to the other. High latency is that super annoying lag you get on a video call, where there's that awkward pause between when someone speaks and when you actually hear them.
So, who actually gives you this pipe to the global network? That would be your internet service provider, or ISP. They're the company you pay every month to build and maintain that connection from your gateway all the way out to the rest of the world.
So our network is built. It's connected to the entire world. But you have to remember, that connection is a two-way street. With all of this data flying back and forth, how do we make sure it's all safe? How do we guard it?
Probably the best way to think about network security is like you're building a digital fortress. You need multiple layers of defense. We're going to look at three really critical layers: the gatekeeper, the secret code, and the secure handshake.
Your first line of defense is always the firewall. This is your fortress gatekeeper. It stands right at the edge of your private network and the public internet, and its job is to inspect all the data trying to get in or out. It follows a really strict set of rules, and it blocks anything that looks even a little bit suspicious.
Next up, we've got encryption. This is our secret code. What encryption does is it scrambles your data into a completely unreadable mess before it even leaves your device. That means even if a hacker somehow manages to grab it while it's in transit, all they get is a bunch of gibberish. It's totally useless without the exact key needed to unscramble it.
And finally, for our Wi-Fi networks, we need a secure handshake. The old standard, WEP, was kind of like giving everyone in the castle the same master key. Once a bad guy got one, they could open any door. But the modern standard, WPA, is so much smarter. It gives every single device its own unique key, and it basically changes the lock for every single piece of data being sent. It's a whole other level of security. So we've gone from a lonely island all the way to a connected, guarded fortress. And that kind of leaves us with one big important question. As our whole world becomes more and more connected, who's really responsible for building these digital fortresses and making them stronger? Is it the companies that make our devices, the providers that give us internet? Or ultimately, is it up to each and every one of us?